Is there something else that I need to press here? Or?
Plug into your device.
This is connected.
Connected adapter.
Okay, what about this? I think it would be easier just to use this one. Like this. This is a laptop one. Connect.
No, it's still the same.
Still the same.
Yes. No, it's HDMI 1.
Sure is. You know, it should be. But that's a laptop too.
This is laptop 2. That one is laptop 1.
Laptop one. Sure is. So it should be okay. Everything should be correct here. There's still no. Still nothing.
Show anything?
What is it?
It doesn't show anything.
No, it doesn't. Oh, there it is. There it is. Okay, fantastic. So what I'm going to do is that I will go and get some coffee.
Okay.
We'll be back momentarily. What the heck, Team Finland? Where are you heading to? Your place is here. Okay. Okay, guys, I will be back momentarily. I will go and get some tea. I'm going to go and get some tea, but for you guys, it's going to be coffee.
Nehän kaikki menee vaan chatilla. Mitä eroa on 2 menee?
Joo, mutta siinä oli se eka lehti ja siinä on se lasku, joka toi tekee tässä kaikkea rotsaa vaan. Mutta sitten siitä pitää selittää sille tekee jotain, mihin se perustuu. Mutta mennäänkö katsomaan esiin varmaan esittäjät ja RMPS? Niin. Jos me nyt koputtelee sen ovelle ja pitää.
Mun mielestä sille voisi mäkin laittaa viestiä, että olisiko niin 3 viikkoa aikaa vai?
Aloittaa mennä suoraan pomolle valmistaa. Sitä kahvilla on siellä, että ottaa kännillä.
Voisi laittaa suoraan
kenkää.
Se on vähän kohtuutonta samalle viikolla. Mä aloitan iltapäivällä näin aikaa.
Se voisi kokeilla laittaa asiallisenkin viestin. Se varmaan todennäköisesti.
Eikö mä sit söin?
Tämmönen voi jatkaa, täällä on varmasti oikein. Se on vähän oikein laittaa.
Se on oikein paljon.
Ei just se.
Minä pitäisi miteniksi siitä muutama vielä. 6 päivää on tosi vähän aikaa.
Aika iso työpaikka.
Vaan että ei tule vastaan yhtään. Tähän saakka aikaa yhtään mitään. Droppasen tavarat vastaan käyttää mitään.
Ei olisi muutos mitään, onko se likatehtävää?
Niin mä just sanoin, että sinänsä voisi vähän fine, jos se likatehtävä ei olisi semmoinen. Tai sitten jos olisi...
Oi.
Toi menee kyllä ihan chatille toi.
100%. No,
Se on onneksi tehty.
30 seconds late. So today it's gonna take. How much it usually take to do the stuff like this? Is it like? So my course. So what is your estimate?
I don't know.
Hour. Oh, you need to, by the way. Oh, the camera is okay. I thought that it's gonna be. Oh, it's blocking a little bit of you, not much. Is it okay if I put this in like a reading mode? Because I think that if I gonna make this kind of the presentation mode, it's not displaying well.
Let's see this way.
But there's a few seconds delay, so how is gonna be here now? Is the same?
Awful.
Awful. Yeah, it's really awful. How about this? Is it any better like that? Oh, no. Yeah. I did this one. How it appears if I do like this? How it appears in YouTube? Still the same.
And also have a functions.
How come it still can be the same? Okay, so let me do this. Let me do this. I think I wanted to change this like entirely. Screen capture. Yeah, that's the way to go. Oh no, this is absolutely not the way to go. This is a way too big. Way too big. There, like this. Okay. This one. Can you check how it appears? Oh, now it's good.
Yeah.
It's good.
So just we have to on your Yep, that's good.
Okay, guys. Respect. One very last time, respect. But I hope that whatever you see me some place inside or outside a university, you say respect, like this. It makes me feel very good. Not long ago, there was a few days back, I was in a gym and some guys went off and they say respect. And my friends were like, okay, don't even tell, I don't want to know. Okay.
Is this the last lecture?
Yeah, this is the last lecture because this is it. This is it.
Okay, so how
Okay,
long do you think
45 minutes, 1 hour.
Okay.
1 hour. Because there's a career counseling and maybe we could have a little bit of discussion today.
Okay.
We'll see. And then, so what happens today is this. So summary, what I'm expecting you to know in last midterm exam. And then I want to show off a little bit about my computer skills. Not my computer skills, but my skills about artificial intelligence. So I did your podcast in English and in Finnish. And it's all related to material that I'm expecting you to master whatever you enter in the next midterm exam. So we're going to take a look at this podcast partially, and then rest I will leave you to listen whatever you have a good time. There's also a video presentation that was made by artificial intelligence, like summary, what is good to you to know when you're entering the midterm exam. And this was pretty amazing. I don't know if you guys ever used a tool that was like, I don't remember the tool right now, but it was like Notebook LM. Have you ever heard about it?
Yeah.
You heard about it? Yeah, it's a really great tool. And I did this, there's a lot of different materials that you can make it out of using this material, but I think it helps you to learn the material. And I upload the lecture material and I was like, make a podcast to me. And I was very excited when I was listening to that. Sometimes in Finnish language it's a little bit clumsy, but not often is very good.
Are you using the paid version or the
Free version.
If
So
you
is
use, if you use the paid version, they can even create the PowerPoint instant.
So better PowerPoint than mine.
Yeah.
But that's very bad news. So what is the use of this guy? So the next year you can say, okay, get off the front of the lecture room because we have a better material to learn. I'm scared. So maybe I don't know what to do. So should I have a plan B? What to do in my life? I don't know. But I was amazed. I was amazed about how good it is. So the paid version gives you the PowerPoint presentation too.
And also the overall infographic, so in one picture.
Okay.
If you upload like whatever the PDF, it will give you like one slide of like infographic.
Oh, really?
Yeah.
Really?
It's amazing.
Oh, that's a really is amazing. It is amazing. But I hope that you guys started to use it. But go with care with that, because sometimes I heard that, particularly when I was listening to Finnish language podcast, sometimes it is not absolutely technically correct, but it's a pretty. I mean, that is a way more interesting to listen that podcast to listen to me, to be honest, because it was like very entertaining. There was two persons discussing about the hydraulics, male and a female. And they were really carried away about how exciting is a hydraulics. And that's interesting. So we're going to listen a little bit about that podcast, but then, like I mentioned, I will leave rest of that stuff for you to listen, whatever is a good time for you to do so. All right, so recap would be the one thing to do, and then there's going to be career counseling. Whatever I'm moving to career counseling is okay to leave. And the reason is that, of course, a career counseling is not going to be part of the midterm exam. This is something that if you figure out the life and what to do in your career, go someplace else. Maybe this is something that is pretty obvious to you. Let me correct myself, this is a particular design for international students. There are a few tips, a few websites that you need to be aware of, because those websites helps you to find a summer trainer position, master thesis position, if you're looking for a paid position. But I'm going to discuss about what are the different opportunities and what are the ways you can find a topic your master thesis work. Okay, so that's going to be career counseling. That's where we're going to wrap up everything. So that's the very last thing that I will explain you today. And in this class anyways. And for one important note is that the next midterm exam covers 4 weeks only. It's 4 weeks material only, so not that much. So it's fully focused on hydraulics. There's a little bit of things related to embedded technique, but embedded technique plays a minor role. Hydraulics plays the major role. So if you're busy, like I know you guys are busy all the time, focus on hydraulics. And then the visiting lecture is something that is, I recommend you to listen to the podcast related to visiting lecture and leave it in that level. That should be enough. And the midterm exam goes same way that the first midterm exam, so it's going to be Moodle based. And again, you're allowed to use whatever tools you want, including the lecture notes, whatever you feel that is necessary to use, and we'll see how it's going to go. Okay, so that's, now why this noise, I don't know. Okay, like I mentioned, so embedded technique, hydraulics, and visiting lecture, and again, related, there are star ranking here. So clearly the most significant, most important one is the hydraulics. The visiting lecture and the embedded technique, leave it if you're busy. All right. Keep this in your mind. So this is how the grading goes. So I don't know if you have been able to count your percentage where you are at the moment, but if you're getting more than a 35% and you're looking for a grade 1, you're off the hook. So you can start doing something else, if this is what you want. And if I don't know if it is possible to get 87% is without participating the next midterm exam, I doubt. Then, but if you have already that much and you are aiming to, you're going to get that 5 out of 5, you can start doing something else. Okay, but there's one thing that I need to discuss with you, and this is that. Because in my first lecture, I mentioned that the next midterm exam will be in week 50. And my question to you is that because this is the last lecture in this lecture season, so would it be okay if we put the midterm exam on already getting started from next week, Monday, right after midnight? And then you have a 2 weeks time to do your 2 attempts. And it's going to be closed, whatever is a week 50 Sunday. I just don't know that I don't remember that by heart. I can take a look at the calendar. So just to give you exact dates. So I'm proposing this. So the exam will be on on 8th of December at 0:05, right after the midnight, and it's going to be closing at the 21st, and that's going to be just before the midnight. How that sounds? 2 weeks time, 2 attempts, hired will be accounted. And you can use any tool you want, including your lecture notes, whatever material you feel that is going to help you to survive in a midterm exam, go ahead and use it. Okay, and again, my recommendation, please take a look at this, today's lecture, listen to those podcasts, use a ChatGPT and others, but go careful with the ChatGPT, because we learned already in the first midterm exam that sometimes it can get confused. So you are the one that is like quality manager. So you need to make sure that whatever is that you're getting out from the ChatGPT or other tools, make sure that you kind of doubt. And then collecting information from multiple different sources. Don't use other students, because that's not cool. And then that's the way to go. Okay, sounds good. Good. Now let's look at what's the deal with this embedded technique, what is a hydraulics, and what is a visiting lecture. Embedded technique was all about this. So this was the last visit in multi-body system dynamics. And I know that is a little painful visit back to the multi-body system dynamics, but it was all about this equation of motion, this one here. Sorry guys, I this morning when I left from my home, I forgot my iPad back to my home. So I don't have an iPad, so I cannot do any drawing stuff of these slides. Sorry about that. But anyway, so you see my pointer here. So this one here is inertial forces. And inertial forces is mass matrix multiplied by acceleration and quadratic velocity vector. Quadratic velocity vector because the way we define the kinematics, that's where it comes from. And then this one here, which is the last component in the equation, is externally applied forces expressed in terms of generalized coordinates. And now in concept of virtual work, this all is multiplied by delta Q. And we discussed earlier that you cannot put this equation as it is here equal to 0. And why not? Because the virtual displacement is imposed to all the coordinates. And when you do so, you're going to violate against the constraints, because the constraints are not accounted. Now, the question goes, like how you can possibly express this guy, delta Q, in a way that the delta is kinematically admissible, kinematically possible, how that goes. And it goes in a way that you're using concept called coordinate partitioning. In coordinate partitioning, you categorize your generalized coordinates to 2 different categories. The one that is called dependent coordinates, another one that is called independent coordinates. Basically, you can do this selection as you wish. There is, however, certain limitations. And in practice, this is made by using Gaussian elimination with the full pivoting. Sometimes it's called full pivoting, sometimes column pivoting. Column pivoting means that sometimes the columns in your Jacobians are reorganized. That's what it means. Anyways, based on your selection, you define your coordinates, the dependent and independent ones, and then key to success is your independent coordinates. Then you just express your virtual displacement, this guy here, by using independent coordinates. And when you build this relation, which is based on Jacobian matrix, then you can relate virtual displacement of all the coordinates and independent coordinates. Why? Why you want to do that? Because then, when you do so, where is my pointer here, then the virtual displacement is expressed in a way that is not violent against the constraints. So no violation. And that's fantastic, because then you can express this equation, or you can set this equation to be equal to 0. All right, so the very last thing to do is that this guy 2, which is an acceleration, needs to be expressed by using coordinate partitioning. And when you do so, this is finally how the equation of motion looked like. So this was something that was explained by Alfonso. And I was following the Alfonso's recordings, and he's a pretty outstanding teacher. So I was super happy to have Alfonso here. I don't know how you find him in guided tutorials, but he's a great guy. hopefully watching this YouTube too. Another high risk. So my life is surrounded by risk. First there's AI, then there's an Alfonso. Soon the Alfonso comes here. Aki, take your stuff and go home. I'm going to take care of the rest of the class, so that's it. Oh my God. Don't know. High risk here and there. All right, that's about embedded technique. Hydraulics. That's a real deal. That's where you need to focusing on. And the hydraulics, there are a few things to consider. First, about the properties of fluids. Lamp fluid theory, for sure, is something that you need to master. Flow types, modeling of hydraulic components. Basically, you need to know the direction valve, pump, and a cylinder. Those are the 3 components that I'm expecting you to master. And that's it. And then deformable bodies, that's not the case. So this is something that I said this whizzing lecture. All right. Hydraulics, properties of fluids. There is a really nice story when you listen to the podcast about the viscosity. You know, how the viscosity can be defined. Viscosity for us is not very important. And it's not very important because it only matters, it only plays a role in practice if the flow type is a laminar flow. And we don't really deal with the laminar flow. And that's simply because laminar flow takes a place when the pressure difference is small. Small is unclear statement, but the small, let's say that if it is less than 5 bars, which is very unusual case in a mobile hydraulics and industrial applications. Usually when you deal with the proper hydraulics, the pressure differences are significant, tens of bars easily, if not hundreds of bars. And that's something where the flow type for sure is going to be turbulent. In a turbulent flow, viscosity in theory is insignificant. Right, so the viscosity is only important in case of laminar flow. But what is super important for us is another properties of fluid, and that's a bulk modulus. A bulk modulus is same than elastic modulus. It's kind of defining how rigid is your hydraulic circuit. And it's very good to keep in mind that the hydraulics often can be more flexible than any of the mechanical component. This is a very typical case in certain cranes. When you see the crane is vibrating, so you're wondering where the vibration and the flexibility is coming from. It's not necessarily coming from the deformation of the mechanical component, but it's coming due to the deformation of hydraulic actuators. Hydraulic actuators are flexible, and they deform or they move because of the loading for 2 reasons. First of all, the fluid itself is it can be compressed. That's the first reason. Another reason is that the containers, whatever, steel containers, hoses, and so on and so forth, they deform too. And combination of 2 things makes or introduce the flexibility related to hydraulics, defined by bulk modulus. Effective bulk modulus, to be more specific. Bulk modulus for a fluid itself only. Effective bulk modulus takes everything into account. Okay, so those are the 2 things. And this was how we defined the bulk modulus. So bulk modulus was relation about how is volume difference versus the pressure difference. This is where it came from. And when we defined that for random size volume, this is where we end up to have. And this is a combination of 2 things. All bulk modulus and the flexibility of the 2 containers combined. So that's where it comes from. This is called effective bulk modulus. This is called just the bulk modulus. All right, that's the way to go. Lamp fluid theory, extremely important thing. So lamp fluid theory, it is something that is more than that, just this one simple differential equation, way more than that, because it's almost like a mindset. Mindset in a sense that the use of lamp fluid theory gets started when you look at the hydraulic circuit. You look at the hydraulic circuit, that you discretize your hydraulic circuit within the volumes where you assume the pressure to be equally distributed. That's the first thing to do. And then you kind of need to make some kind of graphical representation to you, like where are the volumes that you're assuming pressure to be equally distributed. And then once you have these volumes, you also need to make a simple drawings about how you're assuming the positive flow rate to be. And you can do this any way you want. I mean, the flow rate can have any direction, positive direction, any way you want, but something that is important, and you just need to be consistent. And this is a typical problem when you're modeling the hydraulics by yourself, is that you're not consistent. Sometimes you're considering the flow rate to be leaving, sometimes coming, and any mistake like that makes your hydraulic model to explode. And that's sometimes hard to debug. It can be super painful to debug, but if you just keep these drawings in your mind, it's going to be going fine. Right. So the concept of Lamb fluid theory, it goes in a way that you take your hydraulic circuit, you divide that to the volumes where you are assuming pressure to be equally distributed. And then in each of these volumes, you are computing the pressure at any given time by using the first order differential equation. And combining connection of different volumes goes through the flow rate. And different kind of components, regardless what they actually look like, will be just described by flow, how they limit the flow between these volumes. So this is this famous first order differential equation. Components included are as follows. First of all, we have here flexibility, which is effective bulk modulus. So the flexibility is included. Then we have a volume size here. And then, of course, we have two components that are telling how much flow comes in, how much flow leaves. And then the last component is like how much the volume itself changes. And this is only valid component in case of a hydraulic cylinder. Other components, you really don't need to worry about that at all. So that's Lamb fluid theory in short. Okay, then moving forward. Flow types, like introduced a little while back. So we have two different flow types. Now, there's a lot of details involved, but I don't want you to get confused about the details, but instead take a look at the big picture. Now, the big picture is such that whatever you deal with, the laminar flow, pressure difference, and the flow rate are linearly related. There's a linear relation. How is this linear relation? This is going to be defined by case. It's a case dependent. And you can find a lot of pre-calculated tables that helps you to compute the CL component here. So that's something that you can get it from literature. But there's something that I would like you to pay attention to will be the relation between the flow rate, this guy, and the pressure difference. And again, linearly related. Completely different concept when you look at the turbulent flow, because in a turbulent flow rate and the pressure difference are quadratically related, meaning that the pressure difference is here under the square root. And that makes a completely altogether different behavior. Altogether different behavior as is a quadratic or linear relation. So again, where you can get these different parameters, you can get these different parameters by following the concept called semi-empirical modeling approach. A further figure in a semi-empirical modeling approach is our good buddy, Professor Heikki Andrus. You do know that. So Heikki's middle name could be semi-empirical modeling, but it's not. But it could be in theory because he was one of the founders of this kind of the method where you take a look at the parameters here, you modify the parameters in a way that you can get the unknown parameters directly from manufacturer's catalog. That's super handy because otherwise these parameters are painful to get, particularly in the case of turbulent flow, because it becomes to be like, this is the discharge coefficient, CD is okay, you might be able to get it, but many others, like if you really look at how is a cross-section area, it could be painfully difficult to get. And you don't need to worry about it if you're following this semi-empirical modeling approach, because then you just take a manufacturer's catalog, take a look at the performance curves, and get the parameters you need, and you're good to go. That's how it goes. All right, valves. Valves in general consist of two steps. The first step is that you need to model wherever the moving component is located at. Typically the valves, they have a moving component of some kind. Even in the puppet valves, on-off valves, they have something that is on or off. You need to know where this moving component is located with respect to house of the valve itself. Once you know that, then you have an opportunity to estimate what is the size of the orifice, what is the size of the throttle, and then you can model the flow rate through the component. But the first thing first, you need to know where the spool, whatever is a moving component, where that is located, and then the rest is like any other component. All right, so here is a good example about the semi-empirical modeling approach that I mentioned you earlier. This is a throttle valve, simplest, for sure. The simplest possible valve that is in this planet. And here, what you need to get this kind of the valve, you need to know the diameter of this throttle here. Seemingly simple parameter to get. In practice, it can be super painful to get. And again, you don't need to worry about it if you're following the concept of semi-empirical modeling approach. You just combine each of the parameters here, and you express those by using one single variable. And this one single variable is meant to be something that you can get directly from the manufacturer's catalog. All right, these were the valve, the flow equation for a certain kind of direction valve. And again, what are the two steps that I mentioned you a little while back? First step, where the spool is located. And here we are making an assumption that the spool is always following the control signal with a certain delay. With a certain delay, because physically it's not possible that the spool jumps from one location to another. That is not possible because of the inertia, because of the infinite amount of force that the magnet can move the spool back and forth. So it follows, but with a certain delay. And this certain delay can be modeled by using this first order differential equation, which is nothing but delay. This one single parameter needed here, this tau here, where is my pointer, this is something that you can get directly from the manufacturer's catalog. You just look at something that is called Bode diagram, which tells you how well a valve can follow the sine signal. And when you keep on increasing the frequency of the sine signal, certain point the valve is no longer to follow it, and it's being left behind. And when it's being left behind, this is when you know that how fast is your valve. Generally speaking, hydraulics can have a frequency of, I would say, roughly 45, let's say 40 hertz. That's kind of pretty much the maximum that you're capable to move the hydraulics. If there's any vibration higher than that frequency, forget about using the hydraulics. Because there is often an idea that, hey, why don't I use hydraulics to damp the vibration? Which is a great idea. But because of all these flexibility associated to hydraulics, how fast is a valve, so on and so forth, it comes with a certain delays. And that limits how fast you can move your hydraulics. And as a rule of thumb, something that is below 40 hertz, maybe you can damp those by using hydraulics. But again, maybe. It would be more safe if it is less than 20 hertz, then the chances that you can damp those by using hydraulics becomes to be significantly higher. And again, there's a way that you can make your hydraulics to be faster. Those ways are that you can have a little bit of faster direction valve, and you can increase the flexibility of hydraulics by using pipes instead of hoses. Hoses are not a good idea. And if you can take your pump as close as possible to your actuators, this typically improves their flexibility too. So those are the two tricks. And again, so these are the valve or the flow equation for a direction valve. And again, this is what you need first to be able to evaluate where your spool is located. A spool can have multiple different locations, multiple different locations. An idea that was invented some 10 years back was that, okay, instead of using this kind of like analogic valve where the spool is moving all possible directions and all possible locations, what if using digital hydraulics? The concept of digital hydraulics is to replace the spool by multiple on-off valves. And this is what Alfonso explained to you. I don't think the valve, digital valve itself, is made your life much better. Because the big problem in hydraulics is that you keep on wasting energy. And you keep on wasting energy because basically in hydraulics, you keep on pumping the energy your system needed or not. And you do that because of the pump design. But there is a kind of great innovation that is a combination of digital direction valve and digital pumps. And digital pumps would operate in a way that whatever the valve tells the pumps that we need some energy, then the valve makes a decision to put some energy to the system. And if the valve is telling that energy is not needed, there's like bypass valve that takes the flow directly back to the tank. So then you don't pressurize your flow for no good reason. So that's something that is, at least in my mind, one of the best ideas so far. Some people, particularly in our Department of Energy, let me correct myself, electrical department, they said that the hydraulics in general is no good. So you need to get rid of it. And you need to get rid of it that by using electric drives. Yeah, maybe. But problem in electric drives, particularly if you want to introduce a linear motion, the power density is not too great. And it's expensive because you need to have a ball screw and all this kind of stuff. So it's going to be easily very heavy and also very expensive. So another idea that again came from the Department of Electrical Department was to combine your pump as close as possible to your hydraulic cylinder. Something like your pump is operating directly the cylinder. This is how you can possibly get rid of all the losses that is coming along with the hydraulics. And whatever you're lowering down your system, you can put your pump to move backwards and you may be able to collect some energy. This is in theory. So there is no, in my mind, there is no good industrial applications in that regard yet available. But that's another opportunity. Okay, so that's about hydraulics. And these are the last slide about the hydraulics. For some reason, I wasn't able to make this drawing to be good. So the pump is producing flow rate. Keep this in your mind. This is a little bit a chicken egg question. Like what comes first, pressure or flow rate? So we have made an agreement that what comes first is a flow rate. And if you limit the flow rate, then comes pressure. And that's how the pumps are operating. And the way you can describe this flow rate, there were multiple different ways to do it. In a simplest possible pump model, which is a fixed volume pump model, is producing always the same amount of flow, sometimes limited by max power of the motor. That's it. And in load sensing pumps, is a little bit more clever and it can adjust itself to whatever energy is needed in the system or not. And then another way around, when you're converting your hydraulic energy to mechanical energy, then you need to get a hydraulic cylinder. And the hydraulic cylinder, you just take a pressure in a piston side and piston rod side, you differentiate those, you take a minus between these two forces and that's it. And of course the friction comes into play, and friction because of the sealings. And the hydraulic friction is, sealing friction is a little bit a complicated thing. And this is where you often meet something that is called stick-slip friction. I don't know if Alfonso explained this to you. But this kind of friction that makes a little bit of noise. He explained that to you, I suppose. Like, based on your face, it's like yes and no. All right. Okay, the stick flicks is, let me see if I can make it demonstration. I cannot make a good demonstration here, but you know, every now and then when you move a table, you hear this noise, like this kind of noise. So this is when the system is sticking and slipping. And the same kind of thing happens quite a bit in, it can take place in a hydraulic cylinder. Makes a little bit of noise and is something that can make your system to be hard to control. Then the highlight of today's lecture is this. This is a mind map. And I use this notebook, LM. Mind map. I'm going to offer all this material to you. I don't know if they're going to be if they make any good for you. But this was something that I was very excited, very, very excited. This is, let me see if I can hear.
Welcome back to the deep dive.
No.
So if you've ever seen one of those colossal excavators lifting just tons and tons of material, or maybe a massive crane stretching up into the sky, what you're really looking at is the raw, invisible power of hydraulics. And today we're doing a deep dive into what it actually takes to simulate that power digitally. We're going to move beyond, the simple CAD drawings and get into this really complex world where Fluid, welcome back to the deep dive.
Sorry. I cannot make it play through those loudspeakers. But again, this is a material, this is a podcast. Listen to it. You're going to be astonished. But again, there's no guarantees here. So if no warranties. So if there's something incorrectly explained in a podcast, I'm not going to take a responsibility of that because it wasn't me. It was all the time this notebook LM. But again, if you feel that it helps you to understand, go ahead and use it. And I have the same story but in Finnish, and it goes like this.
Tervetuloa mukaan. Olet lähettänyt meille aika vaikuttavan nipun luentomateriaalia Mechatronisen koneen hydrauliikan simuloinnista.
Melkoinen paketti tosiaan.
Kyllä. Ja meidän tehtävä on nyt suodattaa siitä sinulle ne kaikkein kirkkaimmat helmet. Eli tänään pureudutaan siihen, miten insinöörit onnistuvat kesyttämään nämä uskomattoman voimakkaat ja monimutkaiset järjestelmät tietokoneen sisälle.
Aivan.
Tavoitteena on ymmärtää tämä virtuaalinen maa.
At least it's pretty entertaining, if nothing else. When I was listening to this, I was like, what? Again, I'm scared. Like, can we guys keep this as a confidential information? And we are not going to tell this to the rector because as soon as the rector hears this, he's going to let each of the professors to go. Because what's going to be where he needs us anymore? Good question. And then this is another thing. So I made this YouTube video out of this material.
You ever look at a massive piece of construction equipment, like an excavator, and just wonder, how on earth do they design that thing? I mean, you can't just build a bunch of them to see what works, right? That would cost an absolute fortune. No, they have to build it, test it, and perfect it digitally, right on a computer. So how do they create that perfect digital blueprint? Right, that's the big question, isn't it? How do you actually do that? How do you take the incredible raw power and the delicate control of a multi-ton machine and bottle it up inside a piece of software? Well, the answer is you build a simulation, a digital twin so accurate it can predict exactly how the real machine will act and...
Pretty nice. Okay, so that's entertaining material, but again, your responsibility. No guarantees from my end because this is something a little bit unclear to me. So what if I'm able to pinpoint the technical mistakes? So is there any way that I can go and say that this notebook LM that you have a mistake and you need to correct it? Do you know if there's...
I think you can give a prompt in that there's 3 dots.
Okay, and I can say, okay, this is incorrect. So go ahead and correct that.
I'm not sure that you can correct it, but you can give a prompt to make to adjust it.
Okay, yeah, all right. Yeah, I'm very much a beginner of this business, so I don't know how it goes. But
It really depends on what you import it in the dev here.
Yeah.
If you put like a text, like PDF, they understand it more.
yeah, I did that. I uploaded an entire hydraulics lecture material on it, and this is where that came out from that.
If you put more pictures in the dev, like if the PDF has like more pictures in there, they don't understand it quite well.
Yeah, exactly. All right, so I did the one in Finnish, another one in English, and like I mentioned, there are a few things that are a little bit clumsy. They're not proper. I mean, not exactly, let's say, engineering Finnish, but it's quite entertaining. And these guys are male and female. They are very much carried away about hydraulic modeling, which I really never see that in real life. And this is something that at least I think it was quite nice. And I will do the same for also this other lecture material. But again, I was not aware of this until yesterday, so that's a little too late. Sorry about that. All right. So that's about it. Visiting lecture, the same story. I did this. You have these slides, and then you have this.
Welcome to the Deep Dive, the show that digs into a stack of complex sources to give you the fundamental knowledge you need, your shortcut to being well informed.
Today we're getting into something really fascinating. The world of high-fidelity simulation.
Okay.
That's right. We're looking at Project Chrono, which is its incredibly sophisticated...
This was based on the lecture material, lecture slides only. But and again, no guarantees if it is correct or incorrect.
Miten sä testaat Mars-mönkiä, kun et sä voi lähettää mekaanikkoa perässä?
Joo, hyvä kysymys.
Tai miten sä opetat itse ajavan auton väistämään vaaratilanteen, jota ei ole todellakaan turvallista luoda tositilanteessa?
Niin.
No, vastaus on tavallaan fysiikkapohjaisessa simulaatiossa.
Okay, so that's it. That's it. Yeah. All right. So
Welcome to the Miten?
that's it. That was the last slide of technical matters. So now you guys off the hook. If you want to go, it's okay to go. Should we have a short break, or because I know that there may be a little bit of social pressure to those ones that would like to leave right now. Should we have a short break, like 2 minutes, and then come back and then continue with the career counseling, or are you guys okay if I just continue? You want to hear? Even the Team Finland would like to hear about the career counseling.
What now?
You want to hear? You want to hear about the career counseling, or not so much?
Sure, yeah.
Not so much. Why not? So no, what's the harm? What's the damage? So there may be a minor damage, but that's about it. Yeah. And what else you can do this time of the day? So it's 5 p.m. Okay, career counseling. So a few notes about what is ahead of you, because I'm mainly focusing on something that is important decision you need to do quite soon. And this is your master thesis project, because you are now first year master level students, each one of you. And it's not going to take too long before you need to select where you want to do your master thesis project. And some of you might get started even upcoming summer, although that it doesn't look like the upcoming summer is never coming, but it will come. It will come. And some of you will do it exactly a year from now. So the last ones will get started end of the year 26 or beginning of the year 27. And the beginning of the year end of the year 26 is not far off. So it's 12 months and that's it. So a little bit about what in my mind makes sense to do. What are the small tips here and there, like, okay, what is that you should focusing on? But first I need to tell you this. Roughly 90% of the masters, and this is all the students that are getting the master degree from LUT University, and this is valid for other universities too, are moving away from university. So they're moving to industry. They're moving to really wide variety of different kind of the positions out there, but they're out there. And this is good to keep in mind. Because some of you might think that I want to stay in academia. It's not going to be that many of you. But each year, the Department of Mechanical Engineering is producing roughly 10 doctors. And we're producing a little more than 100 masters, so it's roughly 10% that stays here. Some of the doctoral students are not ones that are getting the degree here in LUT University, but another way around, some of you were looking for opportunities to do your doctor degree other universities in Finland or outside of Finland, which is okay too. Okay, so 10% stays in academia, 90% goes to industry, and if looking further, once you get your doctor degree, the situation looks even worse than that. So now 75% of the doctors, so let's say that we got these 10 guys, 10 doctoral students each year, 7.5, let's round it up, 8 of 10 will go back to the industry. And then 2 only stays here, and one of them both of them basically stays in the research line. They may be every other year, every 4 years, there's one that is hired to be as a teacher, university teacher. This is very unusual case, very, very unusual case. So industry is the way to go. So it's going to happen anyways. Sorry, I'm going in the wrong direction. So this is just a little bit like what are the difference between the master level students, doctoral students, and the postdoc, because there's only a handful of you guys. I don't think it makes much of a sense to look at this too much in the details. So I'm going to leave this as a lecture material. So those of you that are seriously considering the academics as one of the career opportunities, take a look at this in details. But for rest of us, let's focus on industry. What makes sense to do in industry? Okay, so I'm gonna get started from the little bit of hints, and then we're gonna move on to the master level thing. So one of the things is that you need to dream big. So it's something that is, I would like you to have a little bit of bigger dreams and just get your master degree. Something that whatever it is that makes you happy in your life, start thinking big, because there's a high risk that your dreams might get true. That can happen. And it is a part of the story, part of the thing here, because you guys are selected to be one of the best universities worldwide to get your master degree. And I'm saying that worldwide because LUT ranking, worldwide university ranking is roughly, is it like 250, roughly that neighborhood. And there's tens of thousands of universities. So this is definitely one of those high-ranked universities, one of the best. And it means a lot, whatever you're looking for, your career opportunities. All right, time management is a key to success, but the attitude is what matters more. Attitude. This is a difficult thing. Like, how is that you can demonstrate your attitude? This is hard to tell. But I think it is a little bit something that don't be too shy. This is particular, I don't know if it is a cultural thing, but sometimes there are Finnish students that they're like, yeah, not me, so don't make any coffee to me, I will be okay. Forget about this. And start having something that is like, be proud of yourself and make sure that others know that you're coming from one of the good universities. You know, I do the different kind of sport and I participate in this Strava. Strava, I don't know, you guys know what Strava. But not with my real name, but with my artistic name. My artistic name in Finnish is Uho Elvis. First name Uho, sukun, then last name Elvis, Uho Elvis. That's my artistic name. And that's a little bit like what kind of attitude I have. So in English, that's the Plaster Elvis. First name Plaster, surname Elvis. And this is like showing off, very much showing off. I know that it's very against the Finnish culture, like, because here we're supposed to be modest, for the reason that is unclear to me. So why you need to be modest all the time? That is a little bit unclear to me. All right, then comes something that is hard to practice. And there's actually really good YouTube videos about presentation skills, oral presentation skills. This is a thing that becomes to be increasingly important. And why is that? Because technical details becomes to be less harder to adapt. And this is simply because of the ChatGPT, this Notebook LM and others. So this is where you cannot make much of a difference against your peers. But your presentation skills, that's a fantastic asset. And now you might say that, no, yeah, not for me, because I'm not a really good presenter, so it's not for me. That's not the case. Presentation skills is like any other skills. Reading, writing, riding bike, you learn by doing. You can easily practice it. You can take a look at these YouTube videos that are helping you to get started. The rest is a matter of practice. Just keep on practicing, and it makes a huge difference in your life. Because storytelling skills, amazingly enough, matters more than how you can solve the partial differentiation equations. Particularly today, because if you cannot solve by yourself, you can make use of your good body, ChatGPT, and ask, like, how can I solve this? And it solves like that, just like that. But can it tell the good stories? No, it's you. You can tell the good stories, and that's it. All right. And then the criticism is something that sometimes, particularly those ones that are staying in academia, sometimes are not able to deal with that. The criticism is something that is a part of the deal. And don't take it like a criticism that is against you, but it's an opportunity to learn more. That's something that is extremely important. And try to make reasonable amount of stuff in your plate at any given time. This is a typical problem, particularly in international students. You want to complete all the courses in one semester. And then things are not working so well, and you're going to be very much stressed, and everything goes to the south, so things are not going well. Manage your time well, build your networks. Build your networks. It's a big problem today in a university because there are so many students that never come to universities in person. They are only following the lectures online. Bit of the problem, because you do need your friends. You need it. I don't know if you use this. Is LinkedIn the best social media that helps you in your career? I'm not sure because I'm not much of a social media person. My social media appearance is limited, very much limited. But which one you guys are using? Are you using LinkedIn or LinkedIn? Any other stuff? Is it Facebook only for elderly people like me, or is it like no good anymore? So what do you do? So what is your social media appearance, if you have one? LinkedIn, I guess. OnlyFans. That's another way to go. So on which side of the table you are in OnlyFans? So both sides. Okay. But that's a part of the networking business. Okay. Let's a little bit of more help, more about a little bit of more stuff here. You can get it all, but it can come with a big price. There are super successful professors in my field, but this is all they do. They don't have much of a other life than being a professor. This is a pretty significant sacrifice. So you can dream big, you can get it, but make sure that if this is what you exactly want, because sometimes you can get it, but it comes with a price that is bigger than you might think it is. All right, then this is something that is a important thing to do. So it's very important to be able to identify your strengths and weaknesses. And weaknesses, you just make a list of it and that's it. Don't let them to hold you back. This is extremely good advice. So like I have a hard time about the writing stuff. Today is not a big problem because of all these ChatGPT and others, but I don't care. So this is something that it's not going to hold me back. So it's going to be still fine to deal with. Today is easier than it was a little while back. But again, that's seriously my weakness. But, when dealing with the new tools and everything, so it's not something that is holding me back, but it's good to focus on your strength, whatever it is that you feel that is very good at. Don't try to be perfect all the time. Stay focused and avoid getting lost in details. Here comes a detail. Sometimes I see that, some of you are scoring 4 out of 5 from this course, simulation of mechatronic machine. You get upset. You come to my office and say, oh my God, I'm going to kill myself. And then I'm like, why? Because I score 4 out of 5 in this class. I cannot live my life anymore. This is it. And then it's like, why? Because I have to score each of the courses, I have to score 5. And then ask him why this is so important. Because, otherwise no one can hire me. And that's not correct. Sometimes when I discuss with HR people, by the way, this week, Wednesday, is a fantastic opportunity to discuss with HR people because there's, what is this day called? Dune Day. So there's a lot of company representatives coming over to LUT University. So go there and try to get to know them. So these ways, when these HR people, when I ask what kind of people are you hiring, they say I want to hire persons that are scoring all the numbers. So when I look at their curriculums, I want to see 5s in certain courses because it's demonstrated that I'm interested in something. I want to see 3s because in some courses it's like I don't hate it, but I don't like it either. So it's like I just pass it with the good grades, 3 out of 5. But I also want to see 1s. Sometimes you need to score 1 out of 5 because that demonstrates that you're fully focused. You are not taking each of the courses seriously. There are some courses, but I know that what the Finnish people are thinking, that there needs to be one course that you have to score 1 out of 5, and that's the Swedish language. But there could be another course too. There could be not just that course, but there could be mathematics. This course, you say, couldn't care less about Aki's stories about podcasts and everything. I just hate it. Fine. You score 1 out of 5 and you're good. Then you're just telling whatever you meet these HR people that, have you ever met the Aki? So if you have, then you know the reason that I scored 1 out of 5. That's simple like that. I hate the math subject matter, and that's great. Because you need to focus on something, but don't think that you always need to score 5 out of 5. Don't think about that. And then this comes out of the experience. So when we're hiring the doctoral students, I keep on asking from my colleagues, how is it you can find the fantastic doctoral students? And the answer is by luck. Because what matters the most is an attitude. Attitude you cannot really measure before you're actually hiring the person. Then once you're hiring the person, then you will figure out if the attitude is there or not. Because everyone can pretend, usually these interviews when you are applying the position is like 15 minutes to 1 hour, half an hour, 15 minutes to half an hour. Everyone can pretend to be a good person in a half an hour. Even I can make it happen. But can you do that in the long run? You cannot. So it's always a big question mark. So it's not easy to know. But again, it's a better story if you say that you have all the numbers in your curriculum. All right. Then moving forward to create a realistic plan. This was a little bit like don't put too much in your plate. Try to include 25% of the overhead. I think it is even need to be more than that, but at least 25%. Seek mentors, peers, colleagues, career counselors. You can use me. So it's okay if you reach out to me later once you are from the LUT University and you're applying the position in someplace else. You can ask, like, can I use you as a reference? Sure, of course you can. Of course, because I'm for you guys. I'm here to help you. Or can you write me a reference letter? Sometimes I can, but sometimes what they do in other universities, they send me an email directly, asking me to write a reference letter, something that you don't see that. This is simply because if I say that, okay, this student is no good, so I don't want to send this to you first, and then you see like, why? I thought that you love me, and now you say that you are not so good student, and you cannot, there's no use of the letter like that. You just have to put it in a trash bin, and that's it. Okay, but seek mentors, peers, colleagues. Another way to say that you need your network, but network is not necessarily your peers, but it can be your supervisors, your teachers, because we're here to help you. Each one of them. Sometimes you might feel that we are not playing in the same team, but we do. So we have the same dream. The same dream is that we hope you guys to get your master thesis diploma, master hat. No, there's no hat, but there is a diploma. There's not even diploma, isn't it? Because it's okay. We're hoping you to get an email that tells that you got your degree. So that's a big dream. So what a shame. It's supposed to be a hat, sword perhaps, maybe weapon of some kind, but I don't know. But it's not just the case at the moment. Okay, remember this. Carrier is an endurance sport. Don't do this as putting pedal to the metal. Car people like, you know what it means when you put pedal to the metal. So you go too high speed all the time. So this is an endurance sport. Don't work with the full capacity all the time because you need to have a certain capacity if things getting really hard. So that's necessary. Give a credit to yourself with your whatever accomplishment you have made. Like if you were able to pass this course, make sure that you can celebrate. I know how some of you are celebrating. This is the one way to go, but you can go anywhere you want. If you feel that taking extra cup of coffee is a good treat to yourself, go for that. So whatever is the way that makes you feel happy. Look 5 to 10 years ahead. This brings me to another topic, which is master thesis. Master thesis, because this is the one that defines your 5 to 10 years ahead. Because depending how you're selecting your thesis topic is important. It is an important subject matter because it is your speedway to industry, or it might not be. Okay, Mustafa is here already. So let me mention a few things here. So you can get the topic from multiple different sources. You can get it from the professor, which is very unusual case. And if you get it from the professor, it counts with the high chance that you are not able to get the financial compensation out of the master thesis topic. We'll get back to this financial compensation, but basically what helps the most is that you need to be active by yourself. And this website mentioned here, this one here, this is hard to memorize if you are not fluent in Finnish language. This is where you can see all the companies that are active in Finland. So take a picture of that. And this is of course in the material that you're gonna have an access later. So check it out, what this can offer to you. This website, you can use it in Finnish or you can use it in English. You guys, the Finnish students, for sure you know this. Correct. You don't. Okay. This is a really good tool because it's organized by one of the unions. The unions that are specialized in technical works, technical aspects in Finland. Okay, supervisor might have a topic for you, may provide the contacts. That sometimes is the case. Like, there are companies that are reaching out to us and say, hey, if you have a super good student right now, why don't you just give me a hint? Yes, sir.
The website, I cannot open it.
You cannot. So let me go through the end of my presentation and then I will open for each of you so you can take a look. Okay. So the supervisor might get it. You can, or he or she might tell you where to get it, and then also telling what kind of topic is okay. Usually we're pretty flexible. So the topic, it doesn't define much of your grades or how is your future, but where you're gonna do your work, that defines quite a bit. And for international students, if you're looking for a position in the industry, making your thesis in the industry is gonna be the fastest possible way to find yourself in the industry. All right. And then sometimes you can select the topics you're interested in, what are your strengths or weaknesses. So if there is a topic that is like theoretical derivations of finite element method and you had never heard about the finite element method, don't take a topic like that because it's not going to land well. So take something that you're good at. At least you have a basic knowledge about it. Because, there is this balancing thing. This being a plaster, having the high self-confidence, and then you might do something that you don't have actual skills to make it happen, which is a very high risk too. You need to have a certain level of knowledge there. All right, this is summary, industry, position after the thesis project, salary. Those are the very big benefits to get your master thesis topic in the industry. And here comes something that is very, very important in my mind. Because if you think that you look at the 5 to 10 years ahead of yourself, then maybe you want to do your thesis without the maximum financial compensation. Because it's you that's going to benefit end of the day. You're the one that will learn because this is a part of the learning process. And so I would kind of encourage you to look at the positions that are not necessarily full paid or not paid at all. Because when you do the thesis in a place that you're dreaming of, it's going to make your life 10 years, 5 years from now to be significantly more pleasant. Because sometimes, and I know that life is hard and everything, sometimes there's students that are knocking each one of the professor doors and asking, do you have a thesis topic? We usually say, yeah, we do. Okay, so when I get started? You can get started right now. So how much is the salary? Oh, no salary. Then it's like, oh my God, I'm going to go someplace else. And you can go someplace else, that's fine. But think this, because it's you that is going to win anyways, regardless of salary or not. Okay. University, support of the professor. I don't know if it is a big deal because you can get it anyways. Location doesn't matter too much today, so not so big deal. But it's good to know, particularly if you do your thesis industry, it's good to be aware of what are the other responsibilities. Because sometimes they say that, okay, so we're hiring you as a thesis worker, so every other Monday you can spend 2 hours just doing your thesis. Rest of the time you do the other responsibilities here in a company. This is very bad deal, very, very bad deal. Because if you're not fully committed to your thesis, you can do the math by yourself. Because this is a 6 months project, and if you do that every other Monday, 2 hours, it's going to take 20 years of your life, which is not going to be, of course, the case because university is going to kick you off after a certain period of time. But you need to be able to find a position that you can actually focus at least big portion of your life is focusing on your thesis. Sometimes thesis hurts physically, which is okay too, because everything that comes with a certain amount of physical pain will remain the rest of your life in your head. And sometimes the thesis is actually the case like that. Okay, salary. The salary is something that I keep on telling, but it is true that most of the companies, they are offering the financial compensation in 2 possible ways. They can give a salary directly to you. Then you make a deal, you and the company. You make a word contract, and that's the way it goes. Sometimes companies making the notion to something that is called support foundation that is located in university. And then the support foundation gives the money to you. It will take some amount of way before the money goes to you. That money that goes to you will be tax-free. So that's another mechanism. That's something that usually the amount of money you can get it through the support foundation, I think it is a 10,000 or 12,000, depending on what kind of deal you can negotiate with the company. And sometimes you ask my help to you to get a better salary. I don't do that. I don't call the companies, every now and then there's a request from the student, like, my salary sucks. Can you call my supervisor and negotiate a better salary? No, I cannot do that. This is a deal between you and the company, and if you take whatever salary, that's your deal. I cannot be your father the rest of your life and calling your supervisor, no, my student is not treated well, he needs to get a better salary, or he or she needs to get a better salary. That's not the way it goes. All right, so you can take these topic ones only. Keep this in your mind. You cannot restart your thesis topic frequently. That's not just possible. It's a once and once only. That's it. All right, these are a little bit of, this is about the support foundation, salary from the company, salary from the university, no salary. These are the options. But again, either way you go, you are the ones that is going to win anyways. Okay, nature of the work. This is a 6 months project, independence work. It shows your maturity, that you can do something independently without too much guidance. You will get certain amount of guidance, but not like hands-on daily help. That's what it is. Demonstrate your ability to solve large problem, and usually it's 6 months dedicated in a way that they are like midterm discussions, you need to demonstrate what are the things you have put it in a writing within the months, intervals, or sometimes 2 months intervals, and then there's a final evaluation. That's how it usually goes. Final thing, instructions. All right, make a table of content. This is something that you're going to get this information once you're really getting started in your work. Make a table of content, because that works as a little bit like a guideline too. In a good table of content, you have 5 chapters. First the introduction, then the method, then the results, discussion, and conclusions. That's in a good thesis work. But when you have it, it's good to monitor your time management. Like if you have spent the first 3 months to write an introduction, you know that this is not going to go well. So it's good to try to use your table of content as your timetable too. And it's good to organize a kickoff meeting, make high quality literature review, extremely important. Use a Google Scholar, Scopus, and Web of Knowledge, and start preparing the manuscript from the beginning. And this is just one course. Sometimes people are like, oh my God, this planet have to turn around and start rotating in an inverse direction. It's not going to happen. It's still going to be one single project. It's going to be significant in your life, but in a big perspective, it's still one project. Consider like that. All right. So student, instructors, supervisors, that's how it goes. And that was my last slide. See you soon in a simulation laboratory course. This was my last slide of today's lecture. Sorry, Mustafa, it took 10 minutes more than I thought. Okay. So material, including this podcast and everything else, is going to be available in a Moodle database. And then just let me take a look at this. This is a website. Let me try to make this bigger. Oh, this is a really... Let me see if it goes correctly. This one. Then you can switch this in English. Can you take a picture of this? Oh, it's very easy, this website. Workbook.
What kind of information?
So what you can find here? You can find here like how you can make your, there's a career planning. You can search positions here. You can accept it all. Find a job. Career services, hidden job, social media. There you go. Take a look at, there's a lot of different kind of material available here. Work Life Toolkit in Finnish. It used to be here that you can find all the companies that are looking for master thesis workers. Is this still the case? Where can I find it? You're not guys familiar with this website? Oh, I was about to get familiar with this. Career services. Oh, these are the university positions. We don't care about that. Job. Oh, these are the different positions available. But these are the different companies that might have positions available. Oh, this is your recruitment companies. Okay. All right. Anyways, time to go back home. So this was it. So see you guys around, and see you in some of you in a simulation laboratory course.
Thank you.
Respect.